Good morning, dear students. Last class I have finished all types of problems from rate measure. It is one of the first lesson in application of derivative, and even I have finished different types of problems on different types of diagrams like rectangle, cone, sphere, circle and cube, like that. On different types of diagrams I have finished different types of problems with respect to its area, its volume, like all those questions I have finished in the last class, and also we have discussed about all these also. To solve like all these questions from rate measure, we need important formulas of mensuration. Without mensuration formulas, we can't solve like all these questions in application of derivative. That's what I have mentioned also. Even I have told about all this. Must learn to remember all types of formulas from mensuration. And what you have learned in lower classes like 8th, 9th, 10th, that is what you have learned about all these mensuration formulas in your lower classes. But we need like all those formulas to solve some different types of problems in exercise 6.1. Today also we'll discuss about a new lesson. That the name of the lesson is increasing and decreasing function. When we are saying that given function is increasing function, and when we are saying that given function is decreasing function, about all this today we will discuss. Here also we need application of differentiation is very important. How to take differentiation with respect to x, that method is very important to show some functions whether they are increasing or decreasing here. Here in case of increasing function, to all types of problems, we are going to take differentiation with respect to x only. We need only first order, enough. And before this, in first lesson rate measure, we have taken differentiation with respect to time, because we have seen some different types of questions like centimeter per second, meter per second, and centimeter per minute, meter per minute. Like all those situations were there in those questions of rate measure. Now in this question we will not see like those situations in the questions of increasing and decreasing function. Just we need first order differentiation enough to solve like all these problems of increasing and decreasing functions here. Now let us, we are going discussing about definitions of increasing and decreasing functions now. Increasing and decreasing functions. Increasing and decreasing functions. Increasing and decreasing functions. Decreasing functions. Functions. First function is increasing function. Increasing function, first one is. Let y is equal to f of x. Let y is equal to f of x be a function. Be a function defined at x is equal to a, then, or such that if dy by dx greater than or equal to 0, or we can write f dash of x greater than or equal to 0. F dash of x greater than or equal to 0, then f of x is said to be, said to be increasing function. increasing function. Increasing function. Any function, if we can take one function here, y is equal to f of x, one function, we are going to defining that function some at x is equal to some real number. Then if we can take differentiation to this, and afterwards if we can compare the differentiable function whether it is greater than or equal to 0 or less than equal to 0. If it is greater than or equal to 0, then that function is said to be increasing function. Here we are seeing two symbols here, greater than or equal. Without equal, only greater than means, then that function f of x is said to be strictly increasing function. Strictly increasing function. Greater than or equal to 0 means then that function is called only simple increasing function. Simply we are calling increasing function, totally increasing function, that is. Only strictly greater than 0 means we are calling that function is strictly increasing function. How means I will show you now. And for that I am going to mentioning that point under the note of increasing function here. Note here. If f dash of x greater than 0, strictly greater than 0, then the function f of x is said to be said to be strictly increasing function. Strictly increasing function. Strictly increasing function. That is the difference between increasing and strictly increasing. Afterwards, how we are showing strictly increasing and strictly decreasing in the intervals, in the open intervals, about that also we will discuss. Firstly, I am going to telling about all these definitions of increasing and strictly increasing, and afterwards decreasing and strictly decreasing both are giving same meaning, and for both those two only less than 0 only. About that also we will discuss now. Decreasing function, decreasing or strictly decreasing function. Decreasing or strictly decreasing function. Decreasing function or a strictly decreasing function. Here also same, it is opposite increasing. In case of increasing, we have taken greater than or equal to 0 means increasing. Strictly greater than 0 means we are calling that is a strictly increasing function. Now in case of decreasing is, and for this also I am giving definition. Let's y is equal to f of x. Let y is equal to f of x be a function defined that x is equal to a, such that if dy by dx less than 0, or we can take like this, f dash of x less than 0, then f of x is said to be, f of x is said to be strictly decreasing function, or simply we can call it also decreasing function, strictly decreasing function, like that. Greater than or equal to 0 means, already I have told two definitions. If it is both greater than or equal to 0, is equal to 0 or greater than or equal to 0 means we are calling that increasing function. Strictly it should be mentioned mandatory, but greater than 0 means we are calling that strictly increasing function. Now it is the decreasing means the opposite to that increasing function. Let y is equal to f of x be a function defined at x is equal to a, such that if dy by dx greater than 0 or f dash of x greater than 0, then f of x is said to be strictly decreasing function. Like that we are giving definition for strictly increasing function. And for both those two we need first order differentiation. After getting that differentiation to the given functions, we have to check them whether they are greater than 0 or less than 0. If strictly greater than 0 means strictly increasing, if strictly less than 0 means strictly decreasing. About these two we will discuss to the different types of problems in exercise 6.2. Let us, we are going discussing about strictly increasing and strictly decreasing in the intervals. How we are going to showing those given functions are strictly increasing or decreasing in the intervals. If the given intervals, how we are showing about those now we will discuss. Just now I have told about only definitions, but how to give representation in the intervals, about that now we will discuss. They give problems like this: find it strictly increasing and strictly decreasing for the given function in the interval 2, 3, and all the questions will come in the open interval only. In that open interval, how we are going to showing, how we are going to representing the given functions are strictly increasing or strictly decreasing, about that now we will discuss. Strictly increasing, and strictly decreasing, decreasing functions in the intervals, In the intervals means we are taking only open interval here. See here, let y is equal to f of x. Let y is equal to f of x is defined in the interval open interval a be like this, a comma b here, such that such that if f dash of x is less than 0 in the interval then f of x is said to be strictly decreasing function. Strictly decreasing function over the interval or in the interval AB here. It is the open only. Open means excluding endpoints. Just include all types of numbers between A and B. For example, 2 and 4 are there. Excluding endpoints 2 and 4, what are the real numbers between 2 and 4? We must consider about all these here. Like that, its meaning is open interval A comma B means exclude endpoints, include only what are the inside of the A and B, what are the real numbers are there, we must consider them only here. At the same time, it is the if f dash of x less than 0 in the interval, then f of x is said to be decreasing function in the interval A comma B. Interval nothing but this is only what we have taken interval A comma B. We must consider this only for this interval here. At the same time, we are going to discussing about increasing function also here. Next point is if f dash of x greater than 0, if f dash of x greater than 0 in the interval A comma B, f dash of x greater than 0 in the interval A comma B, then f of x is said to be strictly increasing function. Strictly increasing function in the interval strictly increasing function in the interval A comma B here. Like that, they will ask the questions in the interval means we have to check like these according to strictly increasing function definition and strictly decreasing function definition like this. After getting differentiation with respect to x, we have to check the values in that interval at the values of that interval. By checking those values, whether they are greater than 0 means then we are taking nature of that function is strictly increasing function. If it is less than 0 means we are going to considering about that nature of the function is a strictly decreasing function. See problem, they will ask like this: show that the given function f of x equals some 3x plus 5 is strictly increasing or strictly decreasing in the interval some 2, 4. Otherwise, first way of solution is after getting that differentiation, to get the values we must and should the differential function equal to 0. By equating that 0, we are going to get in the values. Based on that values we are getting the intervals, and afterwards we are going to checking the in those intervals whether it is increasing function or strictly increasing function or strictly decreasing function. And after checking that, we are going to writing what are the nature of the functions, we are going to writing to those functions now. Like that we are going to solution to the problems of strictly increasing and strictly decreasing functions. And we will see like those for problems in the exercise 6.2. So let us now we are going to solving the different types of problems on strictly increasing function and strictly decreasing function from the exercise 6.2 now. Show that the function, exercise 6.2 here, and first question, show that the function given by f of x is equal to 3x plus 17 is strictly increasing on or like this. Strictly increasing on or means they did not give intervals here. See, strictly increasing means after completion of differentiation, whether is it greater than 0 or not, about that now we will check. See here how means I will show you now. Now let us we are going to giving the solution for this question. Now solution is, let the given function f of x equal to 3x plus 17. Differentiation with respect to x. f dash of x is equal to d by dx of x is 1 and t is constant as it is, and d by dx of independent constant is 0 here. That is f dash of x equal to some real number 3 we got. 3 means by observing that real number 3, it is always greater than 0. See, by checking that number 3, is it greater than 0 or less than 0? Easily we can tell about the number 3, it is always greater than 0 for all x belongs to capital R. If we can take a differentiable function, or if we can define differentiable function 3 defined at any real number, 3 is always greater than 0. If it is always greater than 0 means easily we can tell about this, it is always a strictly increasing function for all x belongs to capital letter R. Like that we should write words after completion of this answer. See, that is f dash of x equal to 3, it is always greater than 0. That is implies f dash of x greater than 0 for all x belongs to capital R. For all x belongs to capital letter R. Therefore, we can tell, here I am going to writing the last step. Therefore, f of x is a strictly increasing function. Strictly increasing function. Increasing function For all x belongs to capital R like this. It's a for all symbol. If you don't want to write this symbol, you can write for all, for each, for every. It's V symbol, letter V, and I have written on the horizontal line to this. Cross line means it is always represents for all, for each, for every. To all these three meanings is this symbol represents. That's what. No need of writing for all, and the words no need of writing for all and for each and for every. Directly you can represent with symbol. For all x belongs to capital R. Now let us, we are going to solving another questions. Next questions. Second question. Show that the function given by f of x is equal to e to the power of 2x is a strictly increasing function, on capital letter R. See here, they gave question on exponential function. Already we knew about that exponential function. Exponential function is always greater than 0. That is, the value of exponential function is always positive. Positive means greater than 0. Easily we can tell that the given function is always strictly increasing function on R. But we should not tell like that in that way, because we are in differentiation now. That's what we must tell about this function through the differentiations methods only. How means I will show you now. Let us now, we are going to giving solution for this question is solution. Let the given function f of x is equal to e to the power of 2x. Differentiation with respect to x. F dash of x is equal to 2 into e to the power of 2x. 2 into e to the power of 2x. D by dx of e power 2x is e power 2x. And 2s is d by dx of 2x is 2, because according to chain rule differentiation, in e power 2x we are seeing two functions. Totally e power 2x is one function, at the same time power 2x is also one function. That's what we must take differentiation to each and every function in that one function. I have taken differentiation given two functions. Totally differentiation of e power 2x is e power 2x, and again differentiation of 2x is 2. It is the f dash of x equal to 2 into e power 2x. You can take in place of x any value. You can take 0, 1, 2, 3, 4. You can take any real number in place of x. It is always positive, because e value is 2.712 something. That's why 2.712 something means it is always greater than 0. That's what easily we can tell here. F dash of x is always greater than 0 for all x belongs to capital letter R. X is equal to 0, then e square will come. X is equal to 0 means e power 0 1, 1 into 2, 2 will come. 2 is greater than 0. Otherwise 1, 2e square greater than 0. Otherwise 2 into e power 4, it is also greater than 0. Like that, in place of x, if we can take any real number, the obtaining value is always positive. At the same time, we must try to consider to that value is always greater than 0. If it can be always greater than 0 means we are going to calling that function as a strictly increasing function on capital letter R. On capital letter R means on set of all real numbers. That's what we can write some words after completion of answer. Like this we are going to writing the words here. Here we know that 2 into e power 2x greater than 0, always greater than 0 for all x belongs to capital letter R. That is we can take f dash of x greater than 0 for all x belongs to capital letter R. Therefore we can write finally, therefore we can write f of x is a strictly increasing function. Strictly increasing function on capital letter R. On capital letter R means on set of all real numbers. Like that we are giving a solution for exponential function. Before that, I have given one question on linear polynomial, the linear polynomial function. F of x equal to 3x plus 17 means we are calling that function as a linear polynomial function. Now just now we gave solution to this question. Now this question is defined on exponential function. About that exponential function we have discussed and we have given that solution for this question also. Like that we are giving solution to like all these exponential functions. Now let us we are going to solving now another questions. Next question is third question. Show that the function given by f of x is equal to sin x. F of x is equal to sin x is first question they are asking here strictly increasing in open interval 0, pi by 2. B. Second question, strictly decreasing in open interval pi by 2, pi. Pi by 2, pi. Third question, neither increasing nor decreasing. neither increasing nor decreasing nor decreasing neither increasing nor decreasing in the interval 0 comma pi in the interval 0 comma pi. Like that here they are asking three questions. One interval is 0 to pi by 2 open interval, another interval is pi by 2 pi second interval, the last third interval is 0 to pi. Like that they are asking three questions on the given three intervals here. Already they gave this question is on trigonometry functions. Just you have to apply allied angle formulas. Allied angle means in which quadrant the trigonometry functions are positive or negative. In first all are positive, in second quadrant sin and cosecant are positive, in third tan and cot are positive, in fourth cos and secant function are positive. We have to apply these rules here. But you have to check that differentiable function is coming, which function about that now we'll check. After taking the differentiation to the given function, after that only we are going to checking whether it is positive or negative according to their quadrants. Now let us we are going to checking a differentiable function of a given function now. Now let us we are going to giving solution for this question. Let the given function f of x equal to sin x. F of x is equal to sin x. Differentiation with respect to x. F dash of x is equal to cos x. D by dx of sin x is cos x. Now from this only we are going to checking is it positive or negative according to their quadrants. Now question number 1 is here I am going to giving answer for first question A. Let's x belongs to 0 comma pi by 2 open interval 0 comma pi by 2. 0 comma pi by 2 means it is those values are lies in first quadrant. In first quadrant differentiable function cosine function is always positive. We must and should check whether it is positive or negative in the quadrants with help of differentiable function only here. We got the differentiable function cos x. We have to check whether it is positive or negative with help of this cosine function only here, because we got differentiable function f dash of x is equal to cos x. That's why firstly I have taken x belongs to 0 comma pi by 2. In this case cos x is always greater than 0. Cos is greater than 0 means that implies in place of cos x what we got here from equation 1 f dash of x. F dash of x is greater than 0. Therefore f of x is strictly increasing function. Strictly increasing function. Increasing function in interval 0 comma pi by 2 like this, because cos x is greater than 0 first quadrant. In case of first quadrant cosine function is always greater than 0. Based on that easily we can give answer for first question is f of x is always a strictly increasing function in the interval 0 comma pi by 2. Now let us we are going to giving answer for second question. B. Let's base. Let's x belongs to, for second question is pi by 2 comma pi. Pi by 2 comma pi. In this pi by 2 comma pi means that angle is pi by 2 to pi, excluding pi by 2 and pi. Those angles lies between which quadrant? Second quadrant. In case of second quadrant, cos x is always negative, because in second quadrant sine function and its reciprocal cosecant function, and these two only positive and remaining all are negative. That's what now we are going to discussing about differentiable function cos x. Now if it lies in second quadrant, pi by 2 comma pi means easily we can write cos x is always less than 0. If it is less than 0 means we can write f dash of x is less than 0. F dash of x less than 0 means we can write f of x is strictly decreasing function. Decreasing function in the interval pi by 2 comma pi. Like that we are giving answer for second question. In first question, that function is belonging to first quadrant. Now in case of first quadrant, cosine function is always positive. Means we can take f dash of x greater than 0. Similarly, in the same way, greater than 0 means we can tell f of x is strictly increasing function. Next one is, let x belongs to pi by 2 comma pi. Cos x is less than 0. Cos x is less than 0 means f dash of x less than 0. Then we can tell f of x is strictly decreasing function in the interval pi by 2 comma pi. Like that we are giving answers for first and second questions. Now let us we are going discussing about third question in the interval 0 comma pi. How we are going to showing neither increasing nor decreasing, I will show you now. See here, first, third is, already we got f dash of x is equal to cos x now. About that now intervals that x belongs to. Let x belongs to 0 comma pi here. See here, if you can observe, it is the y-axis and it is the x-axis. It is y o y dash and x o x dash. This x o x dash, like this. If you can take like this, here increasing up to, this is the increasing here up to pi by 2 here. Here decreasing, it will come down here. It is coming down here. It is coming down here. It is pi. Half is decreasing, half is decreasing. That's why if you want it totally means we can't tell neither increasing or not decreasing. We can't tell half. We can't tell totally. We have to give answer to totally that interval 0 to pi. See, half interval, it is 0 to pi by 2 means half interval. In this interval increasing, but in this interval decreasing. If you want total answer means, if you want answer for total interval means, we can't tell. It is not increasing, it is not decreasing. That's what we can tell, that given function is neither increasing and not increasing. How means I will show you. The given function f of x is equal to sin x. F of x is equal to sin x is strictly increasing. Is strictly increasing function. Strictly increasing function in interval 0 comma pi by 2, and f of x is equal to sin x. F of x is equal to sin x is strictly decreasing. Is strictly decreasing. Is strictly decreasing function. Decreasing function in interval pi by 2 comma pi. Half is increasing and half is decreasing here. But f of x equal to sin x. F of x equal to sin x is neither increasing nor decreasing. Neither increasing or nor decreasing function. Nor decreasing function in the interval in 0 comma pi. Like that we are giving answer for this. Half is increasing, half is decreasing. But when we are going discussing about totally, it is neither decreasing nor increasing in the interval 0 comma pi. Like that we have finished like all these questions today. I have told about the definitions of what are the increasing functions, what are the decreasing. At the same time, I have given information and concepts about strictly increasing and strictly decreasing functions. Next class will solve some different types of problems in the intervals. In the intervals, how we are showing the given functions are strictly increasing and strictly decreasing. About all these next class we will discuss. Thank you very much.